Hello everyone, welcome back to the channel. In this video, we'll be discussing about the third problem of today's weekly contest, minimize XOR. The problem states that you are given two positive integers nums1 and nums2 and you have to find a integer x such that x has same number of set bits as num2 and x XOR num1 is minimal possible. Okay, so let's take an example. Let's say num1 is 3 and num2 is 5. 3 is represented as 0011 in binary and 5 is represented as 0101 in binary. So now you can see number of set bit in num2, which is 5, is 2, right? So in our x, number of set bits should be 2, and further x XOR num1, which is x XOR 3, should be minimum possible. So if you look at 3 also has two set bits, right? So and 3 XOR 3 is 0, which is minimum. So answer, or we can put x equals to 3 so that it satisfies both the condition, right? So hope you get the problem. Now let's look at how to solve this. Now let's assume that num1 is this, and as we know, we have to satisfy two conditions. One, number of set bits should be equals to num2. Let's say number of set bit in num2 is these three values. Okay, so first of all, like, number of set bits in num1 is 7 here. 1 2 3 4 5 6 7, right? So there are only three possible cases for number of set bits in num2. Either it is equal to number of set bits in num1, or it is less than number of set bits in num1, or it is greater than number of set bits in num1. So we have taken all the three cases. Number of We have taken 7, which is equals to number of set bits in num1. We have taken 9, which is greater than number of set bits in num1, and we have taken 6, which is less than number of set bits in num1. And we'll see how to solve each of these, and we are done, right? So first, let's talk about number of set bits is equals to number of set bit in num1. If that's the case, we have seen in the sample case as well, if number of set bits is equal, we can simply put the value of x as num1. So basically, we can simply put 1 where there is 1 in the num1 value. Okay, and while we are doing this, we are ensuring that the value of XOR, okay, the value of XOR would be equals to 0, because 1 XOR 1 is 0. So basically, XOR has a property that equal things cancel each other. So 1 XOR 1 will be 0, and 0 XOR 0, 0 XOR 0 will be 0 anyways. So if number of set bits is equals to number of set bits in num1, then we can simply put num1 as the answer, and that's it. Now let's talk about this third case first, where number of set bits is less than number of set bits in num1. So in this case, uh, first of all, you would not want to put 1 here, or put 1 wherever there is 0 in num1. Why? Because it would increase your answer. It will contribute 1 or a bit set at this position, which will increment your contribution to the answer, or contribution to the XOR. You don't want that. You want XOR to be minimum possible. So you would not want to set any of the bit which is 0 in the original num1. Okay, now you have now these choices. You can choose any of these ones and make them set in x. Okay, you have only this choice. So there are only 6 bits. So which one of these will you choose? The answer is, you will choose the rightmost or the leftmost one. Why leftmost one? Because this is binary representation, right? So this will contribute 2 to the power of 0 to the answer, 2 to the power 0 to the answer. This will contribute 2 to the power 1 to the answer. This will contribute 2 to the power 2 to the answer, and so on and so forth, right? So this bit will be contributing the most to the answer. So that's where you would want this bit to go away as soon as possible. So that's where you will start from left and keep on setting the bits in x until you exhaust this number. Okay, and that would be the minimum possible XOR that you can get. Okay, hope this point makes sense. Now only thing that remains is the case where number of set bits is greater than number of set bits in num1, or this particular case. Okay, so now first of all, as we discussed, we would not want to set a bit which is unset in num1. Why? Because this would contribute more to the XOR, and we don't want that. But if number of set bits is greater, we have to set some of these zeros to 1 in this particular in this x. So we have to set one of these or some of these zeros to 1 in x. Now, first of all, I think you now agree that we have to set this once anyways, because this will decrease your jar, and whatever decrease your jar, you want that. So you will first set all the set bits in num1. So from 9, you have already taken care of 7 bits. So now you are left with 2 bits to be set. Now, which of these 2 bits will you set? Or there are zeros before this as well, right? So now which one of these which will you set? Now, as discussed, this will contribute 2 to the power 0 to the answer. This will contribute 2 to the power 1 to the answer, and so on and so forth, right? So you want minimum possible XOR. So basically, so you would not want to set the rightmost bit first. Instead, you would want to set the leftmost bit first. So what you will do, you will start iterating from the right to the left and see whichever bit is unset in num1, you will set that bit until you exhaust that count. Okay, so hope this argument makes sense. Now what we are doing overall, we are first iterating over. Okay, so we are first iterating over the num1 from left to right, and keep on setting the bit which is set in num1 until we exhaust the count. If we still have some count or some number of bits to be set, then we will start from right to left and set the bit which is unset in num1. Okay, so the algorithm is simple. The pseudocode would look something like this. We count the number of set bit, and then we start from right to left, left to right, the highest bit to the lowest bit. Why 29? 29 because the problem states that num1 and num2 can be up to 10 to the power 9. So at most 30 bits can be set. So 29 is the highest one. And if this set bit, now what we have discussed, if we go from left to right, we will keep on setting the bit which is set in num1. So if there is no more required bit to be set, we'll just break. Otherwise, we we'll check whether this bit is set in num1. If it is set, we will set it, right? So that's what we have done. If this bit is set in num1, we set it in x, and we decrement the required number of bit to be set. Now after this thing, we start from the left, right? So we initialize our bit to 0. Okay, and then we keep on checking whether there are still some bit to be set. If there are, then we will find first bit which is not set in num1. So we start from here, bit equals to 0. Now we'll find first bit which is not set here. So in this case, the arrow will come here, and we will set it and decrement set bits num1. Okay, so that's what we are doing. Let's look at the code. The code is very simple. As discussed, we found the number of set bits, and then we iterate from left to right. And if there are no more required bit to be set, we'll just break. If there are bit to be set, if we will check whether this bit is set in num1. If this bit is set in num1, we will set it in x and decrement the number of required bit to be set. Afterwards, we initialized our bit to 0, which means we'll start from right and go toward left. And again, we are checking if there are still some bit which is required to be set. If there are, we'll find first bit which is not set. So basically, we are checking whether until this bit is set in num1, keep on incrementing the bit, and finally we'll land on a bit which is not set, and that we are setting it in x. And then we are incrementing our bit because we don't want this bit. We will be starting from the next bit and decrementing the number of required bits to be set. So hope this solution makes sense. If you have any doubts in the problem, please post them in the comment section below. I will be happy to answer. If you like the video, give it a thumbs up, and do subscribe to the channel if you haven't already. Thank you.